So today we are doing a trie. It's a prefix tree data structure used to efficiently store and retrieve keys in a dataset of strings. And we need to implement insert, which inserts the word search, which finds exact match in the set and starts with, so returns true if there was a word with this prefix inserted. So this is just a standard insert. This we just traverse the tree and we return false if we cannot even traverse the entire word, or if we traverse but it's not an ending node. And finally starts with we just traverse is search but without the boolean check. So for that we create a node, right? We create a node which will like node. Well, we will have pointers to child nodes, of which there is 26, since I guess we only care about lowercase English. I mean, there will be 3 times 10 to 4 calls and 2000 lengths of words. Damn, that could take a while, brother. Yeah, but okay. Okay, so then only thing other we need is that word or like end, right? Which by default should be false, but I guess default value of bool is false, right? Private let's call it like root, right? And then root is new node, I guess. And then when we insert a word, we do this. So node this, you don't have to use this, but we can use this root. Let's go through this, and now if node child, so if we have a node like that or we don't, right, then node child c minus a is equal to new node. Right, so we create a node and then we move to that particular node, and at the end when we inserted the word we do node and true, and that's the whole thing. Now when we search for the entire word, node this root. Now if not node child c minus a, then we return false, right? Otherwise node child c minus a, and now we return node and this is the same thing, except here we return true. So we just traverse down and we don't check for exact match, and for some reason it's here, which I'm not sure if I have like shite implementation or something. Maybe this, I don't know, or too many conversions, or like, I don't know, maybe. I mean, I guess that could do something. Const here. So this is just some constant optimization. Oh. Okay, let's see. So from 31 to 16, maybe if you rerun once more. Okay, 24, that's funny. 18 milliseconds. 20, okay. Whatever, I guess. I mean, okay, what's more to say about it than it's just a try. So, try. Okay. So, we have to create a data structure for the tries nodes. This data structure will hold an array of nodes, array of pointers to child. Okay, so the trie consists of nodes with pointers to child nodes. Consists of nodes with pointers to child nodes with edges labeled with characters and Boolean flag marking if any word ends in that node. A path if a word, so a path in the trie represents a prefix of an inserted word, and a path in the trie ending in a node with end flag set to True represents a word in the trie. Create a node data structure having an array of node with size of the alphabet K26. Okay. And store a single node as the root of the trie. For a insert query, we take the root and go through the characters of the word and traverse the trie. If at any point the node does not have a child corresponding to the current character, we create it. When searching for a word, we just traverse the trie. If we could not traverse the trie for all characters. Okay, so if at any point the node corresponding to the current letter is missing, we return false. We also finally we return true/false based on the end flag of the final node. Search is the same as the prefix. Query is the same as the search query, but if we get to the final node, we always return true, since we are just looking for a prefix, not the entire word. Complexity, well, complexity is what? M per each insert/query call, where M is the length of the query word, since we have to iterate over the entire word and traverse the trie during it, which takes 1 per letter. I need to move by trie. Space complexity is like, I mean, it's not really technically it's like 26 to something, but since we here word would not be in the trie, but in reality there will be some overlap, since each trie row has 26 to n nodes. So we would have to insert what, 26 to 2000, like this, words. We would have to insert 26 to 2000 words to fill it up. But we only insert free c dot to 4 words at most. I don't know, let's look at the editorial, because this is my analysis is dog water. But sometimes the editorial is complete garbage. What? Okay. Okay. That's fair. Okay. Goodbye.